Hello, everyone, and welcome to this session on exploring the future of 3D mapping, AI, LiDAR, and beyond. So, myself Shivam, and today we will take a deep dive into how cutting edge technologies are shaping the way we visualize and interact with the spatial data. For the traditional mapping method to AI driven automation and real time 3D modeling. So the world of geospatial technologies is evolving at an unpredictable pace. So LiDAR, artificial intelligence, and cloud computing are no longer futuristic concepts. They are just transforming industries like urban planning, self-driving cars, and even disaster management. So in this session, I will walk you through the core technologies beyond modern 3D mapping, their impact on various industries, and the existing possibilities that lies ahead. So let's get started. Let me go to the next slide. Before we dive into advanced technology behind modern 3D mapping, let's first understand what 3D mapping actually is. In simple terms, 3D mapping is the process of creating a three-dimensional digital models of a real-world environment, unlike traditional 2D maps, which display flat representation of geographical data. 3D maps provide depth and elevation, offer a much richer and more interactive experience. 3D mapping utilize a combination of technologies such as LiDAR, which is light detection and ranging, satellite imagery, photogrammetric, and artificial intelligence to capture and process spatial data. So these models are then used various industries, whether or urban planning, where cities planner can visualize infrastructures project before they're built, or in automation vehicle which rely on 3D maps. So the evolution of 3D mapping has been remarkable, which one relied on manual cartography and rough terrain models has now transformed into highly detailed, interactive, and even real-time representation of our world. This transition has opened door for innovation and in reality AR and virtual reality VR gaming. So now that we have basic understand, let's explore the key technology driving 3D mapping forward. To understand the 3D mapping, we need to look at its evolution. In the past, map we were mainly created through land surveys and rough estimation. While they serve basic navigation purpose, they lack precision and real-time updates. Traditional maps such as old paper maps and early digital maps provide a fundamental navigation, but were limited in interactivity and accuracy. Over time, advancement like GPS interaction and digital interface improved accessibility, but they are still relied on static data. So the data transforming brought a satellite-based GIS offering better accuracy and global coverage. However, these were still largely 2D representation with limited elevation details. Modern features like interactive GPS maps reshape how we navigate, but they lack real-time adaptability and immersive depth. Today, cutting edge technologies like LiDAR, artificial intelligence, and cloud computing have made 3D mapping more advanced than ever LiDAR captures previous depth data. AI automates complex mapping process and cloud computing enables a real-time global access. This shift toward futuristic maps is navigation with features such as AI-driven navigation and enhanced user experiences through initiative. Immerse designs additionally glowing a cityscape and provide a real-time visualization of urban environment, helping with city planning, disaster response, and traffic management. Looking ahead, through 3D mapping will become even smarter with AI-powered automation, real-time spatial analysis, and interaction with AR VR. The future promise map that not only how the not show the world but also predict, analyze, and adapt to it, transforming industries such as urban development, automation, navigation, and immersive AR/VR experiences. So let's explore how artificial intelligence is shaping the next step of 3D mapping. So artificial intelligence is transforming the way we generate and analyze 3D mapping, making the process faster, more accurate, and automated. In traditional mapping, a significant amount of human effort was required to interrupt data, detect objects, and build 3D models. How AI, however, reduced the manual workload by interactive automation, real-time data processing, and advanced pattern recognition. Let's break down the key component of AI-driven 3D mapping. Highlight. There is an illustration which shows the AI. First is automated detection. One of the biggest challenge in 3D mapping is identify and categorize objects such as building, roads, vegetation, and water bodies. AI-powered algorithm, particularly deep learning models, and train on vast data sets to recognize these features automatically. For example, satellites and drone imagery can be analyzed to detect construction change in a city, allowing urban planner to monitor developments in real time. AI-based detection also plays a crucial role in disaster management, where it can access damage after natural calamities like earthquake and floods. LiDAR processing. LiDAR processing is light detection and ranging technology is widely used in 3D mapping because of its ability. Especially, we will also discuss how it's work in next slide. So it's a basic idea about LiDAR is here. So AI helps in processing this data by classifying terrain features, removing outlier, and optimizing the 3D points cloud. For example, in forestry management, AI can difference between trees, ground surface, and human-made structure, provide a previous data for ecological studies. In automation vehicle, LiDAR combined with AI ensure real-time objects detection and road mapping. And there is real-time mapping. Traditional mapping methods often take time to process and update, leading to outdated information. AI enables a real-time mapping by continuously analyzing incoming sensor data and updating maps dynamically. AI navigation. AI-driven navigation is essential part of modern mapping technologies, whether it's guiding autonomous drones, self-driving vehicles, or robotic system. AI use sensor data to calculate the best possible paths. And there is a 3D model generation. One of the most exciting application of AI in mapping is the creation of high quality 3D models instead of manually reconstructing landscape and structure. AI can take aerial imagery, LiDAR scans, and sensor data to automatically generate digital twins of a real world environment. The conclusion is the AI powered 3D mapping is reshaping industries by making maps more detailed, accurate, and responsive. From smart cities to autonomous vehicles, AI ensure that we can interact with digital environment more effectively than ever before. So head to the next slide. Here is the LiDAR, one of the most revolutionary technology in 3D mapping. So LiDAR stands for light detection and ranging. LiDAR short for light detection and ranging is a simple remote sensing technology that use the pulse from a laser to collect measurement. This pulse helps create 3D models and maps of surrounding and objects. Let me discuss you about how LiDAR was born and its history. LiDAR was generally a combo of first light and radars. LiDAR in inception can be traced back to the 1930s when people realized that solid object could reflect light. After this realization, laser technology was introduced. And how does LiDAR works? The working principle of LiDAR quite simple. A LiDAR sensor quickly sends pulse of light in the form of laser rays. These rays could reflect on surrounding objects like trees, cars, buildings, etc., or directly to the land and however goes back to the sensor after reflecting. Each ray takes a specific time to reach and bounce back from the object. The distance its cover is then calculated using the velocity of light. This known as the TOF, time of flight measurement. A potential LiDAR sends a hundred of thousands of pulses per second. All these pulses are collected, measured, and processed to create a 3D visualization of environment known as a point cloud. There is types of LiDAR, terrestrial LiDAR, airborne LiDAR. So this technology is widely used in automation vehicles where it helps detect obstacles and navigate safely. Uh, so next we will explore how real-time 3D mapping is transforming industries across the world. Uh, Head to next slide. 3D mapping is no longer just about creating static models, it's about real-time spatial awareness. With advancement in AI, LiDAR, and cloud computing, we can now update and visualize 3D map in real time. This is crucial for industries like navigation, where autonomous vehicles rely on live mapping to detect obstacles and adjust routes instantly. Industry using 3D mappings, construction and infrastructure. The construction and infrastructure industries benefit greatly for 3D mapping, utilizing technologies like LiDAR scanning. This sector gain accurate and detailed information for urban planning, construction, project, and environment analysis. With 3D mapping, stakeholders can visualize designs in real world environment, making the decisions process more effective and saving resource during the development. And second, we can healthcare and life science. 3D mapping has played a crucial role in healthcare and life science, providing a valuable insight for researchers, medical simulation, and treatment planning. Techniques such as 3D modeling help visualize complex anatomical structure, making it possible for medical professionals to plan surgeries, design prostheses, and create a customized implant. Additionally, it also helps in assist in study of gene expression pattern and protein structure in life research. It also uses in disaster response real-time 3D. Maps helps a rescue team as access damage, locates surveyor and coordinate relief effort. Drones equipped with LiDAR and AI can map affected areas in minutes, provide a responders with up to informations. There is smart cities also leverage real-time mapping to manage traffic, monitoring infrastructure, and improving urban planning by analyzing live data from sensor and satellite imagery. City planner can optimize energy use, reduce congestion, and enhance public safety. As computer power grows, real-time 3D mapping will continue to transform how we will explore, navigate, and interact with our surrounding. So next, we will look at how cloud computing enhance the accessibility of 3D mapping. As the 3D mapping becomes more advanced, the role of cloud computing is more important than ever. Traditional 3D maps requires powerful local hardware for processing vast amount of spatial data, but today cloud-based solution allow real-time data storage, processing, and sharing, making high-resolution 3D mapping accessible from anywhere. Companies like Google, Azure, and AWS use cloud computing to handle complex geospatial data sets. This enables research developers and business to collaborate remotely and in real time. Cloud computing also supports AI-powered analysis, help detect changes in landscape, track deforestation, and monitor urban growth. It also allows a scalable 3D visualization, ensuring that large cities, entire countries, or even planets can be mapped without hardware limitation. By offering heavy processing to the cloud, 3D mapping is becoming more efficient, affordable, and widely accessible. Next, let's explore how 3D mapping plays a crucial role in space exploration and planetary research. 3D mapping isn't just changing how we see Earth, it's revolutionizing how we explore the vastness of space. From planetary surface to distant asteroid, 3D mapping provides the critical data needed for space agencies like NASA, ESA, and ISRO to unlock the mysteries of our universe. Using satellites, imagery, LiDAR, and radar data, scientists generates high-resolving 3D terrains, models of celestial bodies such as Moon, Mars, and even asteroid. These models play as a critical role in mission planning, particularly for selecting safe landing sites for spacecraft and rovers. A perfect example of this NASA preserves rovers. Before its landing on Mars, scientists used 3D 3D terrain analysis to identify hazards like craters, boulders, ensuring a precise and safe touchdown in the Jeffro crater. Without this technology, mission would be far riskier and less efficient. But Mars isn't the only place where 3D mapping is making an impact. The LRO has been continuously updating detailed 3D maps of the moon, helping researchers studies geological history and identifying potential location for future lunar bases. Similarly, the Mars MRO provides high-resolution topographical data, aiding in research for water source and habitable environment. Beyond the planetary exploring, 3D mapping is also used in studying asteroid mission like OSIRS EX, which successfully collected samples from asteroid Bennu, relied on the precise 3D models to navigate and execute sample collection with pinpoint accuracy. As space exploration expand, future mission will continue leveraging these technologies to explore exoplanets and distinct celestial bodies. Looking ahead, upcoming missions like NASA's and Mars sample returns mission will future push the boundaries of 3D mapping in space explorations. Head to the next. It is the best, and you should explore that in all the missions which I mentioned there. Here it's come 3D mapping in gaming and environment. 3D mapping just isn't just transforming cities and space exploration, it's revolving gaming and entertainment, bringing digital worlds to life with a stunning realism. Modern video games leverage advanced techniques like LiDAR scanning, photogrammetry, and visual 3D mappings to create a hyper-realistic interactive environment. Games such as Microsoft Flight Simulator, Assassin's Creed, and Red Dead Redemption use real-world topography and satellite imagery to generate a breathtaking open world landscape that mirror real life location with incredible accuracy. This level of detail enhance immersion, allowing players to explore digital worlds that feels almost indistinguishable from reality. Beyond gaming, 3D mapping plays a crucial role in augmented reality AR and virtual reality VR. AR applications like Pokemon Go and Google Lens use real-time spatial data to overlay digital objects onto the physical world, seamlessly blending the virtual with the real. And in VR, 3D mapping helps create a fully immersive experience where users can navigate a lifelike virtual space with realistic depth and skills. The entertainment industry is also harnessing the power of 3D mapping to push creative boundaries. Hollywood films and virtual concerts use advanced 3D scanning technology like to build hyper detailed CGI environment and lifelike digital character. Volumetric video capture enables actors to be scanned and placed into a virtual with the incredible details, making digital tower nearly distinguishable from real life performs. This technology is being used in blockbuster movies, virtual production, and even a holographical performance. As gaming engines like Unreal Engine and Unity continue to advance, the future of digital experience will become even more immersed from lifelike simulation to interactive virtual world. 3D mapping is just making all those things so making environment more immersive, realistic, and limitless than even before. So it is it. So to the next slide. So here is Google Earth and Liquid Galaxy 3D mapping. Google Earth utilizing 3D mapping by allowing users to explore the world from their screens. By integrating satellite visionary, LiDAR scans, and 3D photogrammatical, it generates highly detailed models of landscape, cities, and even extra-physical terrains like Moon and Mars. From urban planning to environment monitoring, Google Earth has become an essential tool for visualization and analysis. And for the Liquid Galaxy, enhance this experience by synchronizing multiple screens to provide a seamless, immersive 3D exploration environment initially developed by Google. It is now used in research institute, government agencies, and educational programs. It enables interactive presentation of geographic data, making it valuable for urban development, tourism, and even space mission planning. With advancement in AI and real-time data integration, Google Earth and Liquid Galaxy continue to push the limitation of 3D mapping, offering a deeper insight into our planet and beyond. As technology evolves, the future of 3D mapping will shaped by AI, automation, and real-time spatial computing. One major breakthrough is AI-driven mapping, where machine learning models automatically process satellite imagery, LiDAR scans, and sensor data to generate detailed real-time 3D maps. This allow for instantaneous update, making maps more dynamic and accurate than even before. Another key innovation is autonomous mapping. With drones and robots, this system can explore remote or hazardous areas, generating detailed 3D reconstruction for application in disaster response, archaeological, and planet exploration. Spatial computing. The technology behind AR, VR, and the metaverse is also set of revolutionizing how we interact with 3D maps. Apple Vision Pro, Meta AR glasses, and immersive simulation platform will enable users to navigate digital twins, manipulate real-world data in real time, and enhance decision making across industries. So, looking ahead, quantum computing and blockchain could further enhance 3D mapping by accelerating process speed and securing geospatial data in integrity. For smart cities to space exploration, 3D mapping will remain a fundamental pillar of innovation, reshaping how we perceive and interact with the world around us. Head to next slide. So that brings us to the end of the journey through 3D mapping, AI LiDAR, and future of spatial computing. This technology are rapidly evolving, transforming industries and urban planning. So I hope this session has give you valuable insights into a potential of 3D mapping and how it continues to shape our world. If you have any question, feel free to ask. Let's explore innovation and pushing the boundaries of technology together. Thank you for the watching. So bye.